In this video, we're going to work a bunch of problems where we find the derivative of a function using either the product rule or the quotient rule. So let's get started. Let's find f prime of x. All right, so here we've got one function of x times another function of x. Okay? So the product rule says that this derivative of f prime of x is h prime of x g of x plus g prime of x h of x. Okay, so what is h prime of x? What's the derivative with respect to x of this 3x squared minus 5x? And we're going to put this in one big bracket because we want to isolate h prime of x. Well, in the previous section, we worked a bunch of problems just like this. We use the power rule, the constant multiple rule, the difference or the sum and difference rule. So, okay, this is 3x squared, the derivative of 3x squared. Leave the 3 out front, bring down the 2. So we're going to have 3 times 2 is 6 times x to the 2 minus 1. All right, minus the derivative with respect to x of just 5x. Well, derivative of x is 1. So we're just left with 6x minus 5. All right, so all of that, this is h prime of x, right? Times g of x. G of x is just e to the x. Okay? Plus, and I'm putting these big brackets because, I mean, I guess I didn't have to put that here, but you can get the sense if we had a bigger problem, you really want to make sure you isolate these derivatives you're taking, the derivatives and the functions, the derivatives and just the general function, because you have to multiply all of that together. All right, so, okay, g prime of x. What is the derivative with respect to x of e to the x? That's just e to the x. All right, times h of x. Just write h of x as it is. Okay, so now let's simplify this. So e to the x times 6x minus 5 plus e to the x times 3x squared minus 5x. Okay, so let's factor out an e to the x, and we're left with what? 6x minus 5 plus 3x squared minus 5x. Okay? E to the x. Okay, so we've got 3x squared plus x minus 5. So there we go. That's f prime of x. All right, so we could use the quotient rule here, but we could also write this as x times e to the minus x, right? So let's go ahead and do that and use the product rule. And so this is f of x, and this is g of x. All right, so y prime is equal to f prime of x, g of x, plus g prime x, f of x. All right, what is the derivative of f prime of x? Derivative with respect to x of x is 1 times g of x plus derivative with respect to x of e to the minus x. Well, actually, we don't know how to do that yet. So I'm going to go, let's restart. We're going to use the quotient rule. This is f of x. This is g of x. Okay, so the quotient rule. We have the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay? So what is f prime of x? The derivative with respect to x of just x is 1 times the bottom times g of x minus the derivative of the bottom. What is the derivative of with respect to x of e to the x? It's just e to the x times the top all over the bottom squared. Okay? So this is e to the x minus x e to the x all over, and then this is e to the 2x, right? So we can factor out an e to the x in the numerator, and we're left with 1 minus x all over e to the 2x. Okay, and so this cancels, and this becomes just an x. So we're left with and that's the derivative. Okay, so h of u. Remember, you want to check your variables, because if this was h of x, let's just say this was h of x is equal to this u minus root u, then this would just be a constant, right? Any other variables that aren't listed as part of the function input, are constants. So the derivative of h prime of x here would be 0. But no, these u's are input variables. All right, so let's use the product rule. Here is one function of u, and here's another function of u. Now, to be honest with you, since these are conjugates like this would, if we did this multiplication, expanded this, we'd get something really simple, and we could just use the power rule to find the derivative, right? Because like this is, so if we distribute this, we have u squared plus u root u minus u root u minus u, right? Well, that's easy. We can just take this derivative. But we want to practice the product rule in this video. So let's do, we'll write this as u minus u to the 1/2, and this is u plus u to the 1/2. Okay? So h prime of u is the derivative of the first, f prime of u is what? So derivative of u, 1, minus derivative of u to the 1/2. Bring down the 1/2. 1/2 minus 1 is minus 1/2. That's the derivative of the first times the second plus the derivative of the second, 1 plus, bring down the 1/2, u, and this could be u to the minus 1/2, times the first. Okay, so now that's the derivative. Let's just simplify it. So if we distribute here, we get u plus u to the 1/2 minus 1/2 u minus 1/2 plus 1 is 1/2, okay? Minus 1/2 u to the 0, so just minus 1/2. All right? Plus, let's distribute this here, so u minus u to the 1/2, right? Well, we know the answer is going to be 2u minus 1, right? If we just do this derivative, but okay. U minus u to the 1/2 plus 1/2 u, so u to the minus 1/2 times u to the first, 1/2, minus 1/2, just like that, u to the 0. So h prime u is equal to what? Minus 1/2 u to the 1/2 plus 1/2 u to the 1/2. Okay, u to the 1/2 minus u to the 1/2. So we add the u and the u to u, and then minus 1/2 is minus 1. There we go. Okay, so again, we could do this distribution, and it would probably be easier, but we want to practice the product rule. So this is, we'll say, is f of x, and this is g of x. So, oh no, sorry. F of v and g of v, not x. Okay. J prime of v. What is the derivative of f of v, this first function? So we've got 3v squared, right, minus 2 times v to the minus 4 plus v to the minus 2. Right? Derivative of the first times the second plus the derivative of the second minus 4v to the minus 4 minus 1 is minus 5. Okay, so then we're going to have minus 2v to the minus 2 minus 1 is minus 3 times the first, v cubed minus 2v. Okay, so that's the derivative. Let's just simplify. So 3v squared times v to the minus 4. 3v to the minus 2. Okay? 3v squared times v to the minus 2. That's just 3. Then we've got minus 2v to the minus 4. And then minus 2v to the minus 2. All right. Plus, let's distribute all this. So minus 4v to the minus 5 times v cubed, v to the minus 2, plus 4 times 2 is 8, v to the minus 5 times v to the first, v to the minus 4, minus 2, and just 2, v cubed, v to the minus 3 times v cubed is just 1, plus 4 v to the minus 3 times v to the minus 3 times v to the first is v to the minus 2. All right. So we've got what? 3. Well, what we could do is, this is, let's just take this parentheses out, put a negative here. We'll take this parentheses off. And just do this. Okay. So now let's combine like terms. So we've got this 3v to the minus 2, this minus 4v to the minus 2, and this 4v to the minus 2, and this minus 2v to the minus 2. So, okay, 3 minus 2 is 1. 1 minus 4 is minus 3. Minus 3 plus 4 is 1. So v to the minus 2. And these we're done with. Okay, 3 and a 2, 3 minus 2 plus 1. All right, minus 2 plus 8 plus 6. All right. So j prime v is equal to 1 over v squared plus 6 over v to the fourth plus 1. Okay, so again, it would probably be easier if we just distributed this and used the power rule, but we're practicing the product and quotient rule in this video. So this is h of y, and this is g of y. All right, so f prime of y is equal to, now we can write this as y to the minus 2 minus 3y to the minus 4, and then y plus 5y cubed. All right, so what is h prime of y? Minus 2, y to the minus 2 minus 1 is minus 3. Okay, now bring down the 4. We get minus 4 times 3, so this is going to be plus 12. Y to the minus 4 minus 1 is minus 5. Okay, times the second. Plus the derivative of the second. 1 plus 5 times 3 is 15. Y, 3 minus 1 is 2. Times the first. Okay, that's the derivative. Let's just simplify it, clean it up. Okay, so distributing this, we've got minus 2y minus 3 plus 1 is minus 2, minus 10, and just times 1, plus 12 y to the minus 4 plus 60 y to the minus 2. Okay, plus, let's distribute this here. Y to the minus 2 minus 3y to the minus 4 plus 15, and just 15, and then minus 45y to the minus 2. Okay, now let's combine like terms. So we have the y to the minus 2's. We've got minus 2 plus 60 is 58, plus 1 is 59, and then 59 minus 45 is 14. Okay. All right, minus 10 plus 15 is 5. And then 12 minus 3 is 9. All right, so we've got 14 over y squared plus 9 over y to the 4th plus 5. Okay. We could consider factoring this difference of cubes, x cubed minus 1 cubed, and see what happens, but let's just use the quotient rule here. So this f of x, and this is g of x. I mean, to make it simpler, we could just call it f and g. All right, so y prime is equal to the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. That's the quotient rule. All right, so y prime is equal to the derivative of the top. What is the derivative with respect to x of x squared plus 1? That's just 2x times the bottom, all right, minus the derivative of the bottom. What is the derivative of x cubed minus 1? 3x squared times the top all over the bottom squared. All right, so now that's the derivative. We're done with as far as the derivative is concerned. This is just an algebra problem now. We want to clean this up as much as we can. So let's distribute the top here and then combine everything and see what we get. So 2x to the fourth minus 2x minus 3x to the fourth plus 3x squared all over x cubed minus 1 squared. Okay, so 2x to the fourth minus 2x minus 3x to the fourth minus 3x squared. Okay, so 2x to the fourth minus 3x to the fourth minus x to the fourth minus 3x squared minus 2x. Okay, so now let's factor out a minus x in the numerator. We're left with x cubed plus 3x plus 2 over x cubed minus 1 squared. And there we go. Okay, let's use the quotient rule again. I mean, we could consider factoring. Let's see. So we've got, we're trying to practice the quotient rule, but t squared plus 3. And then if we factor the denominator, we've got minus t minus 3 and t minus 1. So that we can't do anything with that anyway. So we've got, this is f of t, we'll just put f, and this is g. So, okay. The derivative of the top, the derivative of f, is what? 3t squared plus 3 times the bottom, t squared minus 4t. All right, minus the derivative of the bottom, so 2t minus 4 times the top, all over the bottom squared. Okay. So we're done. That's the derivative. With a lot of these derivative problems, it's simplifying it. Using algebra to simplify it is the bigger challenge, right? We want to clean up this mess as much as we can. But that's the derivative. That's it. Even though it's complicated, I mean, that's still just the derivative. All right, so let's distribute this. We've got 3t to the fourth minus 12t cubed plus 9t squared plus 3t squared minus 12t plus 9 minus, now let's distribute this, so 2t to the fourth plus 6t squared minus 4t cubed minus 12t all over t squared minus 4t plus 3 squared. So now let's distribute this minus here. Okay. So we're going to have that minus, then minus plus plus. So minus, plus, plus. Okay. So we've got what? 3t to the fourth minus 2t to the fourth is just t to the fourth. All right. Minus 12t cubed plus 4t cubed is minus 9t cubed. Okay. 9t squared plus 3t squared is 12t squared. Minus 6t squared is 6t squared. Okay. Minus 12t plus 12t is 0. So plus 9. Okay, that's the derivative. All right, so let's use the quotient rule again. We can write this as s minus s to the 1/2 over s squared. Okay, this is f. This is g. Okay. The derivative of the top, 1 minus 1/2 s to the minus 1/2 times the bottom minus the derivative of the bottom, so 2s times the top, s minus s to the 1/2. All over the bottom squared, so s to the fourth. Okay, so we've got s squared minus 1/2 s to the minus 1/2 plus 2 is 3/2 minus 2s squared minus 2s to the 1 plus 1/2, 3/2. Okay, now we can take this off and distribute that minus. Okay, so we get that. Y prime is s squared minus 2s squared, so minus s squared. And then minus 1/2 plus 2 is plus 3/2 s to the 3/2 over s to the fourth. Okay, now we could simplify this. I mean, you could consider factoring. Let's just leave it. I'm going to leave it like this. The book gives this answer. The book says you have 3 minus 2 root s over 2s to the 5/2. So what they do is, I guess they factor out an s to the 3/2 in the numerator, and you're left with what? Minus s to the 1/2, right? Because 3/2 plus 1/2 is 2, plus 3/2 over s to the fourth, and then 3/2 minus 4, which is 3/2 minus 8/2 is minus 5/2. So this goes away and this becomes 5/2. And then if we multiply this by 2 over 2, we get 3 minus s to the 1/2. So over 2s to the 5/2. So if you think that's simpler, you can go with that answer, but I'm just going to leave it like this. Okay, so quotient rule. f prime x, derivative of the top. Well, okay, this is more difficult because now we're taking the derivative of the top. We need to use the product rule here, right? So we're going to put a big bracket, and now we have a whole separate problem here. So product rule, derivative of the first, 2x, times the second, plus the derivative of the second, times the first. Okay, that's the derivative of the top. Now we come back to the quotient rule. That's the derivative of the top times the bottom minus the derivative of the bottom, 2 to the x plus e to the x times the top all over the bottom squared. Okay? Now let's just simplify. So distributing this, we get 2x to the fourth e to the x. No, 2x cubed e to the x plus 2x e to the 2x plus x to the fourth e to the x plus x squared e to the 2x, okay, minus 2x cubed e to the x plus x squared e to the 2x. Okay, now we can distribute this minus here. All right. Let's combine like terms. So 2x cubed e to the x, these subtract out. X squared e to the 2x, these subtract out. We're left with this 2x e to the 2x plus x to the fourth e to the x. We could take out, let's take out an x e to the x. So we have 2 e to the x plus x cubed. And let's rearrange that. Let's say x cubed plus 2 e to the x, just to get this e to the x away from here. So x squared plus e to the x squared. There we go. Okay, so we can write this as x plus cx to the minus 1. Okay. Now let's use the quotient rule. So f prime of x, the derivative of the top times the bottom minus the derivative of the bottom, so 1 minus c, because c times minus 1, x to the minus 2 times the top, all over x plus cx to the minus 1 squared. Okay, so let's expand the numerator. X plus cx to the minus 1. Okay, and then we have minus x plus cx to the minus 1, right? All over x plus cx to the minus 1 squared. And this is, we get this x goes away, and we're left with 2x to the minus 1 over x plus cx to the minus 1 squared. So we can write this as x times x plus c over x squared. Okay, and then in the numerator we've got 2. Okay, wait a minute, I messed something up here. This is, okay. Two cx to the minus 1, right? Cx to the minus 1 plus cx to the minus 1 is 2cx to the minus 1. Okay, so f prime of x is equal to x plus c over x squared, and then 2c.